Okay, this is a problem from the slides, and we're going to calculate the equivalent resistance and take it a step further and calculate the voltage across R1. No, so the voltage across R4 and probably the voltage across R3. So I'm going to draw the circuit. Oops. Erase right there. And so this is R4, this is R5, this is R1, R2, and R3. Okay, so this is 18 volts. So the first thing I want to do is redraw the circuit because if you notice, they kind of trick you here. This is the plus side. So we're going to redraw it over here. I'm going to do R4 first. And R4 then goes out and goes to splits and goes to R1 and R3. So I'm going to go R1, I'm going to go to R3. And notice R1 is in series with R2. So I'm going to have R1 and R2 here. And then both R3 and R2 end in R5. So there's my R5. This is R1, this is R2, and this is R3. And let's write in the voltages. So this is, or the resistor. So this is going to be 220. No, this is going to be 100. 100 ohms. R5 is 270 ohms. R3 is 470. R1 is 220. And R2 is 130. Okay, so the first thing we want to do is we want to combine so that we're given these values and we're going to find first the equivalent resistance. And that's of the total circuit. But as we go, we're going to have equivalent resistances along the way. So we're going to find equivalent resistance. We're going to find, say, V4, the voltage across the R4, and we're going to find V3, the voltage across R3. Okay, so let's redraw the circuit, and I'm going to combine R1 and R2. So I'm going to have this. And so this is 100. This is 470. That's R5, which is 270. Make these a little bigger so we can connect them. Yeah. All right, so what is our R12 going to be? Well, here R12 is in series. So R12 is in series. So we're just going to say R1 plus R2. And that's equal to 220 plus 130, which is equal to 350. So this is going to be 350. We're going to redraw it again. And what I want to do is combine the 350 and the 470, which are in parallel, so that I get R4, so 100. We'll figure that one out. This one's 270. And to calculate, so this is going to be, this now is R12. This is R3. And we're going to call this one R123. And so to find R123, we're going to say 1 over R123 is equal to 1 over R12 plus 1 over R3. And so that's going to equal 1 over 350 plus 1 over 470. And when I plug that in, I'm going to have R123 is equal to 200.6 ohms. So this is going to be 200.6 ohms. Okay, so looking at this, I've now turned our circuit into a voltage divider because I drop voltage across here. If the current is the same through a series circuit, then that means that the voltage drops are going to be proportional to the resistances. So if I want to find, I could do a couple of things. I can actually calculate the current through here and then multiply. If I want to find R4, this one's R4. This is R5. If I want to find the voltage across R4, I can find the total current by finding the equivalent resistance here and then multiplying that current times R4. So let's try that. So I'm going to find current. Right, so what I need to do is find REQ. The total is going to equal R4 plus R123 plus R5. And so plugging that in, R4 is 100 plus R123 is 200. Let's just leave it as 200 plus R5 is 270. And so that's going to equal 570. Okay, so now to find the current, I is equal to V over R, and that's going to equal 18 volts over 570 ohms, and that's 0.03315 amps. Great, so that's the current, and that goes through each, the R4, the R123, and the R5. Now it doesn't go through, I can't say that each of the R1, R2, and 3 use that current, because if we look back at our circuit, we see that the current splits coming out of R4. So the only voltage I can find with this current is the voltage across R4 here and the voltage across R5 here. So let's do that. Let's find the voltage across R4 and the voltage across R5. And then what's left over is the voltage drop across R3 and across R1, 2, 1 and 2. All right, so the voltage across R4 is going to equal I times the resistance of R4. So that's 0.0315 amps times 100 ohms. And so that's going to equal 3.15 volts. And that's reassuring because I have 18 volts, and so definitely I should have a voltage that's less than 18 volts. What about V5? V5 is I times R5, and so that's 0.0315 times 270 ohms. And I'm just going to pull up MATLAB on my other computer. So 0.0315 times 270 is 8.5. So V5 is equal to 8.5 volts. Right, so now I have my voltage drop across R4 here, and I have my voltage drop across R5. And so the voltage drop across 3, if I look back up here, the voltage drop across 3 is going to be the total voltage minus the voltage across R4 minus the total voltage across R5. So we're going to say V3 is equal to 18 volts minus 3.15 volts minus 8.5 volts. So plugging that in, I get 6.3. So V3 is equal to 6.3 volts. And if I wanted to find the, we're not going to do it here, but if I wanted to find the voltage across R1 and R2, if I know the voltage across R3 is 6.3 volts, then I know the voltage across R1 and 2 is 6.3 volts. And that's because the voltage going in and the voltage coming out, right, that's got to be the same for R1, 1 and 2 and R3. So what I can do the same thing and pretend that 6.3 volts is the voltage across R1 and R2, and then I can use the ratio of, say, R1 over R1 plus R2 times that 6.3, and it'll give me that voltage. So again, I can use my idea of a voltage divider there to be able to figure out what the split in the voltages are.